of foot over bridge. Okay. Now in the last lecture we have to cover up to our step number 5. Now in today's session we have to find out influence line diagram of top chord member and bottom chord member, and the design of top chord as well as bottom chord design is done. Okay, so your examples number 2, having the data of you have to design a warrant type of foot over bridge having a span of 18 meter, panel length is 3 meters, so there is 6 panel of 3 meter, width of walkway which is the pedestrian's width having 4 meter length. Okay, another 3 load data in which your first is flooring having the thickness of 120 mm, live load is 5 kilonewton per meter square, and floor finish is 1 kilonewton per meter square. So this data is already given, and in the last lecture we have to cover it up to step number 5, and our step number 5 is very most important. So in the fifth step we have to find out the load on main members. Okay, so our main member is top chord, bottom chord and diagonal members. So in the last lecture we have to cover up to this step in which our total factor load, which is the total dead load plus total live load, is 28.5 kilonewton per meter. Now we are moving further to our step number 6. So our step number 6 is analysis of lattice gutter, in which we have to just take a name of all the junctions. Okay, this is the revision. This all the today's session is the revision of our example number 1's all the members. Okay, now our step number 6 is analysis of lattice gutter, or it is also called as truss gutter. It means you can see that this is our uppermost member, and uppermost member is your top chord member. So that's why upper means U0. So this is your U0, U1, U2 up to U5. And similarly, this is your bottom chord member, and bottom chord is the lowest member. So this is the L0, L1, L2, L3 up to L6. Okay. So this is the only giving the junction's name. Okay. So this is the end of your step number 6. Now, very most important step is your step number 7. Now, step number 7 is forces on top chord, and you all know that this is your U0 member and this is your U1 member. Now, in the end type of foot over bridge, there is a vertical member is also there. But in this type of foot over bridge, there is no any vertical members are there. So if this is your U0 member, it means this is your starting point and this is your ending point of your first member. Now, if there is no any supports in that junction, in that member, then the maximum deflection, okay, the maximum deflection is occur at the center point. Okay, so if your maximum deflection is occur at the center point, it means your maximum load is at the center point. If your load is maximum at the center point, then your bending moment is also at the center point. Okay. So for top chord member, we have to draw an influence line diagram for the center point of all the members. Okay. So you can see that this is your U0, U1, and from U0, U1 your center point is this. Now the equation is remain same for the last examples. It is A into L minus A divided by L into H. Now what is A? A means the center from origin. It means distance from origin. So this is at this point. So from origin your distance will be this, and this distance is 3 meter. So your value of A is 3 meter. L is 18 meter, A means 3 meter divided by L, which is 18 meter, into H. Now H means height of vertical, which is find out in our step number 1, and it is 2.60. So students, after putting all this value, Your answer of first influence line diagram is 0.96. Similarly, your second influence line diagram is for U1 U2 member, and for U1 U2 member maximum deflection occur at the center. So your center point is this, and for this point your distance will be 6 now, okay, because the distance from origin, so this distance is 6 meter. So 6 into 18 minus 6 divided by 18 into 2.6, so you will get your answer 1.53. And similarly your third member is U2 U3, and for U2 U3 your center point is exactly at this point, and for this point your value of A is 9. Okay, so students, after putting all this value we have three influence line diagram, because this influence line diagram and this influence line diagram is just a mirror image of one another. Okay, similarly this influence line diagram and this influence line diagram is also a mirror image of one another. So the force in this first member is also a force in this last member. Okay, so we have to find out our influence line diagram up to U2 U3 point, and our influence line diagram's value is 1.73, 1.53 and 0.96. Now we have to find out forces. So the equation remains same. It is force is equal to area of influence line diagram into UDL. So for first member it is 1 half, base is 18 and altitude is 0.96. So it is 1 half base altitude into UDL. So UDL is our 28.5. So after putting all this value, our answer will be 246.24 kilonewton. Similarly, for second member it is 392.44, and for third member it is 443.75. Now you have three forces, and you all know that you have to design for any component for maximum force. So your maximum force is 443.75 kilonewton. Okay, and your 445.75 kilonewton is your design force now. And you all know that this is your through type of foot over bridge, in which flow system is connected with bottom cord. So when you have to design for through type of foot over bridge, and for top core member you have to design for compression member, and the design of compression member is remain same for our first example. Okay, so students, you have to check your step number 8 is as your homework. Okay, so now we are moving further to our, this is your design of top code, which is the similar method of the last examples. So now we are moving further to the design of bottom code. Now this is your step number 9. So first of all we have to find out influence line diagram for bottom code. But student, this figure is given in your book. Okay, so how this value will be come in your influence line diagram? So first of all you can see that similar funda. If there is no any supports, then maximum bending moment will be generated at the center. So this is your L0, L1, L1, L2 and L2, L3 in the place of U0, U1, U1, U2 and U2, U3. There will be typing error in this slide. Okay. So your first member is L0, L1, and for L0, L1 your maximum bending moment will be generated at the center. Now your center is at which distance? It is 1.5 meter. Okay. So now in this first influence line diagram, your value of A is 1.5, L minus A, which is 18 minus 1.5 divided by L into H, which is 18 into 2.6. So students, after putting all this data, you will get your answer 0.53. But for bottom code, the method of joint will be applicable, but why, how this value is coming from? So you can see that from 0.53 to left hand side you can see that there will be decreasing in the value. And similarly, from 0.55 to right hand side, you have also decreased your value. Now you have to find out at the junction point. It means at L0 and at L1 both the point. So you can see that at L0 point your value will be already 0, but at L1 point your value is decreased or less than 0.53. But how this value will be find out? So there will be trigonometric method in which you can see that this is zero distance, and from this distance to this point, this is your 16.5 meter span. So the value 0.48 will be find out with the help of trigonometric equation will be if your value is 0.53 for 16.5 meter length, then this length is 15 meter. Okay, so equation is 16.5 for 16.5 it is 0.48. Then what is the value for 15 meter? So you will get your answer 0.48. Okay. Similarly, for the second member, it is L1, L2. Now, basically, for practical point of view, your maximum bending moment will be generated at the center. So, your center point is this. So, at this point, your value of A is 4.5. So, A into L minus A divided by L into H. So, you will get your answer 1.30, but this is your junction value. Now how this value can be find out? So you can see that from left hand side this distance is 4.5. So for 4.5 your value is 1.3, but what is this distance? So this distance is 3. So for 4.5 your value is 1.3. So what is the value for 3 meter? So you will get your answer 0.866. And similarly for right hand side, if your distance is 13.5, then your value is 1.30. So what is the value for 12 meter? Okay, so you will get your answer 1.15. And the similar calculation is for L2, L3 member. Okay, so students, from three influence line diagram, you can see that your maximum influence line diagram's value is given in L2, L3. So you have to find out the maximum force for L2, L3 member. So for L2, L3 member, you have to find out forces with the help of area of influence line diagram into UDL equation. Now in this influence line diagram, there is two triangle. If you have to cut this figure from this, then this is your first triangle, this is your second triangle, and this is your trapezoidal. So whenever you have to find out forces, then the area of two triangle plus one trapezoidal. Okay, it means say for example for this it is 1/2, base is 6 meter, and altitude is 1.34, plus second triangle is 1/2, this base is 9 meter into 1.44 plus trapezoidal. Now what is the area of trapezoidal? It is A plus B by 2 into H. So your A is this, B is this, divided by 2 into H. H means this line. So you will get your total area of this influence line diagram, and then you have to multiply this area with your load which is 28.5, and you will get your answer 418.61. Now this is the maximum force. Okay, because you can see that in this there is only one triangle. In this figure, two triangle plus one trapezoidal. So whenever you have to calculate one triangle, two triangle plus trapezoidal, and two triangle plus trapezoidal, you will get your maximum force which is 418.61. Then you will get your answer maximum for L2, L3, and it is 418.6. Now, you all know that Whenever you have to design any structural component, you have to design it for maximum force, and this is your maximum force. Now, similarly, your bottom code is designed for tension member. So, your tension members design is already covered in our last example, in which we have to cover three checks: yielding, rupture, and block shear. So, all the checks will be remain same, and all the methods of design of bottom code will also be remain same. Okay. So, this is your homework. And our last step is design of joint, in which we have to draw top chord forces divided by bolt value, bottom chord force divided by bolt value. Okay. So all the data and all the methods will be remain same as our example number 1. Okay. So students, this is the end of our example number 2, as well as our chapter of foot over bridge. So, in the next lecture, we have to start our next chapter, which is the design of gantry cutter. Okay, so this is the end of our today's session. Thank you.